Yes, Deepak, you're correct. There is a DAG. So maybe the question is wrong. Okay, I will
Ye-
check it. I will just.
yes, ma'am. This question takes me 1 hour.
Oh, yeah, this is not a DAG even. Yeah,
Yeah, there's two cycles, CGH and BGHC.
hmm,
Yeah.
right. Yes.
Thank you, ma'am. This was my doubt.
Yeah, you're right. This is not a DAG even. So you cannot find the topological ordering here. Okay, so let us start. Uh, First, we will cover rest of the topics which was left. Then we will solve some problem. Okay.
Hello, ma'am.
Uh,
Ma'am,
Yes,
the week 11 graded assignment is quite tough. What do you think?
I
हाँ,
haven't seen the graded assignment actually. So
थोड़ा तो टफ है वो.
okay. So basically, what I think you have to only use the algorithms, right, to solve the assignment. Like this should be the case. I don't know. I'm asking you.
कुछ मैट्रिक्स some matrix problem and some algorithms are there.
Yeah. So if you have given the matrix, then try to draw the graph
Oh,
from the
so,
matrix.
ma'am, the last lecture you have discussed these things that in the distance portion. Scroll down little bit. No, 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 no. Just scroll down the lower portion. I want to see. Here you have added vertex 3. Pre-vertex is 2. Okay. But the
Mhm.
distance y you have 70 plus 16. It should be 70 plus 80 plus 6 na.
70 plus 80 plus 6.
Hmm.
Why? We are considering the shortest distance. No? So we are going through this path. Let me use another color. We are following this path. So we will add this respective distance. No? Actually, you need to, whenever we will do this, I mean, for the vertex.
Oh, you are following the shortest path.
Yes, yes.
Oh, so you are avoiding the 80.
Yes, right.
Hmm.
So the method is like you have to look at the previous vertex, okay? Then you just have to add the distance of the previous vertex with the weight of the recent vertex, okay?
So, ma'am, we have to always follow the topological sorting and use the shortest path.
Yes. For a DAG, sorry, yes, for a DAG. But in this case, for this picture, this is not a DAG, right? This graph is not directed, right?
Which question, ma'am?
Yeah.
For this graph, which you can see right now in the screen, this graph is not a DAG, right? So this is not a directed graph, right? So we have both sided here. So this is not a directed graph. So for this kind of problem, I mean, we had the problem to find the shortest path, right? So we use the discard algorithm, and discard algorithm just said ki you have to fix a source first. So here we fix 0 as a source, okay? Then we will choose the edge which is of least weight, okay? So when the source is 0, that means we will start from 0. Then we will choose the edge containing least weight. That is why we choose this weight, because between 80 and 10 is less, right? So similarly, when we add 1, so we have these two edges, right? Connecting with 2 and 4 respectively. So this weight, that means 6 is least. So we will choose 6 then. That means 1, 2 edge then, right? That is how we can move in this algorithm, discuss algorithm. Okay. Fine. Any doubt?
Yeah, hello, ma'am.
Yeah.
Ma'am, could you please scroll down and show the graph again?
Yeah.
Yeah, ma'am. Instead of 80, if there is a 11.
Here, 11.
Yeah. So what will be the shortest path to the Note 3.
Note 3.
0, 1, 2, 3. Yeah, 3.
Okay. So if you have 11, then if we follow the discard method, again we will choose this age. Okay, because of we need to choose the least age. Then again we will go through this way. Okay, so I got your doubt. Okay. Okay, in that case, this should be the shortest path from 0 to 2. And then we should go through this path. But if we follow discard algorithm, then it is guiding us to this path. So, okay, I will think about this problem, then I'll let you know about it. Okay, I need some time to think. Once I
Yes,
get
ma'am.
it, I will.
Sure,
let-
ma'am. Because now, for exploring algorithm
Mhm.
in a single graph, it is very difficult for this algorithm. Because
Yeah.
when we are selecting edges, grouping
Mhm.
of the edges, that time it is possible to get a shortest distance. But in this algorithm, it is I have come across the same kind of situation. So
Yeah.
I'm a little bit confused how to tackle or how to grow the
Yeah, right. This is a little bit confusing. I will just have a look to this algorithm once, then I will let you know. Okay. I will,
Sure, ma'am.
yeah.
Sure, ma'am.
Then I will clarify the confusion. So we know that, like, if you have seen the lectures, then we know that we can face this similar type of problem if we have a negative weight in our graph, right?
Yes, yes.
Yeah, so in that case we cannot use the discard algorithm, right? So for this type of scenario, this type of problem, we arrive to a new algorithm called Bellman-Ford algorithm, right?
Yes, ma'am.
I will again think about your problem because as I know, if there is nothing negative in our graph, then this should be like discuss algorithm should arrive to some conclusion. But here it is again creating some confusion. So I have to check it once, then I will let you know. Okay. So
Okay, ma'am.
yeah. Okay, so as we know, there are some boundaries of the discuss algorithm. That is why we need to arrive to the Bellman-Ford algorithm, right? And what a Bellman-Ford algorithm is, so the initial step, I'm writing the steps here, then I will solve an example, okay?
Hello, ma'am.
Yes.
Ma'am, this when we will able to access the recorded session of that happened in Google Meet?
That means your TA sessions.
Yes, ma'am.
You don't have the access still?
No. In fact, one TA session recorded is not present also.
Okay. Okay. I will let you know. Like, I will talk to Vishal about it. Then I will talk to him about it. Okay.
Okay. Thank you, ma'am.
So initial step is we will create columns. Okay, so our columns will be like, we will note the vertex and we will note the distance, that means the shortest distance of the vertex, and this will be the initial step. So because in this method we are finding the shortest distance from a fixed source, right? So we will fix a source. Just for now, let us consider 0 is the source here. Okay, so I'm denoting the source as 0 here. Okay, so if 0 is the source, so we will write the distance of the source as 0, and initially for every vertex I, we will initialize the distance as infinity. Okay, then we will move through the algorithm and we will then update the distance. Okay, so the formula, we have a formula for the distance, which is distance of the vertex I is minimum distance of I, comma, distance of j plus weight of j comma I. Okay, and what is j? J is a vertex such that there
Which
is
written, ma'am? 0 is a
0 is a
Yes.
source here. Okay, I am denoting the source as 0. Okay,
I is a infinity.
okay, I is infinity means initially we will denote the distance of any vertex other than the source as infinity. Okay, infinity is the distance of the vertex I. Okay, so this is the initial step, this is the initialization. Okay, like suppose we have this case, I mean I, j, k, these are suppose our vertices. Okay, then this is the initial step. Okay, then we will follow some other steps and we will use this definition and then we will update the distance. Okay, am I clear?
Yes, sir.
No.
Yes, ma'am.
No.
Yeah. Who said no? What is your confusion? Just let me know.
Could you please repeat? This was.
Okay. So suppose this is our set of all vertices. Okay, and this contains 0, I, j, k, and so on. Okay, like some vertices like that. Okay, so here we will consider, because the Bellman-Ford algorithm can help us to find the shortest distance from a fixed point, right? So that fixed point is our source here. Okay, so we will take 0 as the source. You can take any of the point as source, but here I am taking 0 as a source. Okay.
Okay.
Yeah. So 0 is the source. That means 0 is a vertex, which is I'm considering as a source. And for other vertex, I, j, k, like this is the general denotion. So for other vertices, the distance will be infinity initially. Am I clear? Right. Initially, we will just use this column. Okay. For source, the distance is 0, and for other vertices, the distance is infinity initially. Okay. Then, as we move to our process, then we will updating the distance of all the vertices. Okay, using this definition.
Okay. Now this definitions explanation. I mean, this.
Yeah. So the definition is minimum of distance of I, like this. These are the initial distance of any vertices, distance of that particular vertex, and then distance of j plus weight of I comma j. So the j is like the particular vertices such that there exists a edge from j to I. That means we will get this type of scenario. Okay, this is a general definition. Okay.
So the
yeah,
minimum distance to I will be the minimum of
this and this.
distance and weight.
Yeah. So distance of I and distance of j plus weight of the edge between j and I. Okay.
Okay.
This is the definition, and so we will, this is just a procedure ki we will initialize our algorithm like that. So we will denote the definition, sorry, the distance of our source as 0, and rest of the vertices, the distance for rest of the vertices will be infinity initially. Okay. Then we will move to our process using this definition. Now I will solve an example so that it will be more clear to you. Okay. So just let us consider the graph. Suppose we have 0 to 1. Okay, suppose this is our graph, and we will just let us introduce the weight now. Okay, so this is our graph, and these are the respective weights. Okay, now we want to use the method to solve, to find the least path, I mean that means the shortest path from the point 0. Okay, this is our source. Okay. So as I said, we will initialize this as this type of list. Okay, so we will have all the vertices. So we will first list all the vertices. So we have 0, 1, 2, 3. Okay, so this is the first step. We listed all the vertices, and as we know, 0 is the source, so the distance will be 0 for 0, and rest of the vertices, the distance for rest of the vertices will be infinity. Okay, this is our initial step. Now we will use these definitions. Okay, so first we will start with 1. The distance for 0 will be 0 always. So the distance of 1 will be, let us follow this definition. So if I check the vertex 1, so we have a incoming edges to 1 from 0, from 2, and from 6, right? These 3 edges, right? So we will consider these 3. So here our j will be equals to 0, 2, and 6. Okay, so this will be according to the definition, distance of 1, comma, distance of 0 plus weight of 0, 1, comma, distance of 2 plus weight of 0, 2, comma, distance of 6 plus weight of 0, 6. Okay, is it fine up to now? This is the definition. Okay, any doubt? No, right? Okay. So,
No doubt.
yeah. So we will just follow this. This is our step. Okay. So distance of 1 is infinity here, right? So we will just follow this step. So we have infinity. Then we will calculate this. So distance of 0 is 0, and weight of 0, 1 is this 10, right? So this will be 0 plus 10, that means 10, right? So distance of 2 is again infinity here. So this will be infinity, and distance of 6 is also infinity. So this will be infinity. Now minimum between among all these 4 term is clearly 10, right? So distance of 1 will be 10. Clear? This is how we can calculate the distance. Okay.
Distance of one from source.
Yeah, from 0. Yes. So 0 is the
This is
source.
weight. This is weight or it's level based.
Yeah, it is according to the weight, because whenever we will have a weighted graph, we will calculate the shortest path according to the weight. Okay, that means the
Okay.
path containing the least weight.
Okay. So this is weight from 0 to 1.
Yes.
Okay.
And what is the weight of 0 to 7, that edge?
0 to 7. Okay, I didn't write it now. I have to check the. Okay. Or let us take it one. We can take anything. So let us just take it one. Okay. Okay. So this is how we calculate the distance of 1. Similarly, we can calculate the distance of 2, right? So we will follow this formula again. So if we check the vertex 2, so we have incoming edges from vertex 2, from vertex 5, right? So this is the only incoming edge, right? From 5 to 2. That means we will consider here our j will be equals to only 5, right? So this we will again apply the formula. So this will be minimum of 5 plus weight of 5,2, right? So clearly all these are infinity. So this will be minimum of infinity, infinity, which is infinity, right? Okay.
This means from 5 to 2 it's impossible, kind of.
No, this is not impossible. So actually, one thing I should mention that we will repeat this step up to n minus 1 time. Okay, where n is the number of vertices. So whatever the final step will be, it will be representing the minimum distance from the source to all the vertices. Okay, so we have to repeat this process n minus 1 time. So here the number of vertices is 7, right? So we have to repeat the process 6 times. Okay, this is our initial step. So then we will repeat the process 6 times: 2, 3, 4, 5, and 6. Okay. So we will get 6 more columns, and whatever the last column will be, this will be our respective answers. Okay. Now similarly, we can calculate the distance for 2, 3, 4, 5, and 6. So you can just calculate it and let me know what will be the distance from 0 to 3. Similarly, you have to calculate it. Just put the values in the definition and calculate. What will be the distance of 3? Check
Infinity.
3. Number of incoming edges, and then this, right? So infinity. 4. For 4?
Infinity.
Yeah. 5?
Ma'am, infinity means false, no?
What?
Infinity means false.
Yeah, not here. This is.
There
You
is
can
no
take it
direct
as
edge. Can we
false,
say like
but
that, ma'am?
what?
Can we say there is no direct edge from the source? So that's why we are making it infinity.
No. That you cannot say. There can be still some direct edge. Okay, from the source. Yeah. Yes, that is right. Yeah. From the source there is no direct edge, but there can be some other vertices from where the particular vertex acts some direct edge. Yeah. From the source it doesn't have any direct edge.
So we were talking about the weights now.
Yeah.
So how we are now reaching to reachability of source to particular point?
Once again.
We were talking about the weights now. So
Yeah.
weight about from the source.
So we will, so we will find the shortest path from source to that particular point. Okay. Here the shortest path means the path which will contain the least weight. So this is our aim.
Then there is a path from 0 to 2, na? 0 to 7 to 6
there
to
is a
5 to
path
2.
from 0 to 2, but as I said, we have to repeat the process 6 times. So at the final step, we will get the final distance from final.
Ma'am, there is a
shortest
pattern
distance.
being formed, I guess.
Yes,
Over
right.
there, 0 and 10 is coming. The next we'll unlock 2 for 2. Is it that way?
Yeah.
Yeah,
So
let's do.
as we will move to one step to another step, the number of infinity will be decreasing. Okay. So let us follow this thing up to 6 steps. Then let's see what is the case. Okay. So what will be the? Let us follow the process. Okay. So what will be the distance for 5?
Infinity, ma'am.
Yeah. 6.
Infinity.
7.
1.
Yeah. Okay. In the next step, we will again do the similar type of thing. Okay. So we will put 0 here. Then what will be the case for 1?
10.
10. Right. 2. You have to check
Every
the
other is-
incoming vertex.
All are infinity then?
Infinity.
Who are
Right.
not reachable from 0, 1, except 1 and 7.
Yeah, so if you are finding the minimum as infinity, then just write infinity. Okay, don't. Can you just mute yourself?
Okay.
Yeah. So don't just run any conclusion from the half steps. Okay, it's like we will only conclude something from the final step. That means from the 6th step. Okay.
Ma'am,
Okay.
Yeah.
Because the edge is directed from 0 to 1, that's why we are counting the weight as 10.
Yeah, so we are following this definition actually. So whenever we were calculating the distance of 1, so we have to consider all the edges, like all the vertices which have direct edge. So we have 0, 6 and 2, right? So the value of j will be 0, 6 and 2 here. Okay, so we have to consider all the numbers. Then we have this and this. Okay.
Go through its wise,
Okay.
Yes.
and we go through its wise, no?
Minimum, not maximum.
Yeah.
Yeah. We will choose the minimum.
Source. Nothing, ma'am. Got it.
Okay. So let us calculate the others. So what will be the distance of 3 in the next step? Infinity, right? Similarly, we will calculate. Okay?
Yes, ma'am.
Yeah. For 4?
Infinity.
Yeah. For 5?
Infinity.
Infinity.
Sure. So whenever you are calculating
No.
for 5, just use the definition. We have 5 incoming edges to 5 from 1, and we know the weight of 1, right? I mean the distance of 1.
Right.
So what will be the 12, right? Correct. Yeah.
Ma'am, how is it 12? Could you?
Yeah, sure. See, whenever we are working with 5, so we have 3 incoming edges, right? So for 5, if we are calculating the distance of 5, our j will be equals to what? 6, 1 and 4, right? 1, 4, 6, right? So this will be minimum distance of 5, and distance of 5 in the previous step was infinity. Okay, then we will take distance of 1 plus weight of the edge, which is 2, and distance of 1 is 10, right? 10 plus 2 means 12. Okay, then distance of 4. So distance of 4 in the previous step was infinity, and distance of 6 was also infinity. So we will take infinity comma infinity. So this will be 12. Okay.
Okay, ma'am.
Now I got confused now.
Why?
Please scroll up. In this one, what was wrong in the previous time when we calculated the 5 weight of 5? Then at that time also we can conclude with 12.
No.
You are saying infinity to all the
Yeah,
points which are.
yes, right. But whenever in this step, when we were calculating the distance of 5, that time the distance of 1 was infinity. So instead of this 12, we were getting infinity in the previous step. So we will take the distance of the previous column when we'll calculate the distance of some column.
So we have already calculated the distance to 1 as 10 now.
So we have calculated this, but in the step 1, right? So when we are calculating the step 1, that means the column 1, this column, then we will take the data from the previous column. Okay, because we are at step 2, that means our column 2. So we are taking the data from the previous column. So in the previous column, the distance of 1 is 10. That is why we can take the distance as 10. But for this column, for the first column, in the previous column, the distance of 1 was infinity. So in that case, we cannot take as 10. Okay.
Okay.
Yeah. So whenever we will use the definition, the data will be collected from the previous column only. Okay.
Okay.
Clear?
Clear.
Okay. Okay. Now let me know what is the distance of 6.
1. Yeah, sorry,
2.
2.
2.
Sure. 2.
Yes, ma'am.
Okay. So how can we calculate this? So we have to check the incoming edges, right? So this is the only incoming edge, right?
Yes,
So
ma'am.
yeah. So the distance of 7 is 1, and the weight of the edge 7 6 is 1. That means this is 2, right? And what will be the distance for 7? This will be 1 again, right? Because we have a direct edge from the source. Okay. Again, in the next step, we will do the same thing. Okay. So we have 0. Now what will be the case of 1?
-2, I think. -2.
-2. -2. Why -2? Okay,
6
2
plus
minus 4, right? Distance
Yes.
of, -2. Okay, we shouldn't get the distance as minus. So we should increase this thing. Okay, let us take it as 8. Okay, so I will update the respective. Then this will be 9. Okay. Now just calculate.
Ma'am, what you just did? Ma'am, what you just did? This 8 and 12.
Actually, I don't wanted a distance to be negative. That is why I just took 8 instead of 1.
Oh, acha. ठीक है.
Now you can do the same thing. Now, yeah, what will be the distance of 1 then?
10.
5.
5.
Yeah, right. For 2?
Ma'am, how it got to 5 now?
Ma'am, who is that unmuting, ma'am?
12 minus 2, it's 10, I think.
Yeah. So we are calculating the distance of 1, right? So we have to again check with all the incoming edges. So we have this, right? So if we consider this one, we will get 10. And if we consider this one, so the distance of 6 is 9, right? So 9. Then the weight of the edge is -4. So this will be 5 then. Okay. So minimum of 10, 5 and infinity is 5, right? Am I clear? Okay. So yeah, what will be the distance of 2 then?
10, ma'am.
3?
12 minus 2, it's 10. Okay.
Infinity.
Yeah.
For 3, it's still infinity.
Yeah.
Yes.
4.
Infinity. Infinity.
Okay. 5. 5. So we have this edges. 6 and 1. We have to
Se-
consider 6 and 1.
8, ma'am.
Yes, right. So the distance of 6 is 9 and the weight is minus 1. So this will become 8.
How 2 is 10?
What?
Ma'am, how 2 is 10?
2. Okay. So we were
Yeah,
calculating 2. That means we have to consider this edges, which is the only incoming edges, right? So the weight of
Yes,
5
ma'am.
is the distance of 5 is 12, and if we are considering this, that means we have to consider this weight minus 2 equals to 10. Okay, and this is the minimum because others will be infinity, right?
Oh, okay. But
Okay. Okay, so what will be the distance of 6?
9.
7?
8.
Okay, again we will do the same thing in the next step. So 0, for 1 it will be 5, for 2
6.
2 also same, ma'am. Wait.
10 means it's 2.
2,
That
there
means
is no other
we
incoming
will
edge, right?
consider this.
Yes, 6.
We will consider this edge. So the distance of 5 is 8, right? And the weight is minus 2. So this will be 6, right? Here?
Yes, ma'am.
Yeah. 3?
Ma'am, what's the difference between 2 to 3? Like it's 1? Is it 1?
2 to 3. Yeah, this is 1.
So 11.
Ma'am, 2 will be 10 only, na?
Why? We will consider the minimum, na? So we have 10, but we have the updated distance of 5 as 8. And this age is minus 2. So we will get 6 again, right? So 6 will be the minimum, right?
Yes, ma'am.
Oh. Okay.
Okay. So what will be the distance of 4? 4. Have to consider the incoming edge means 3, right?
okay.
Check with 3. So
12.
not
12.
what is the weight of 3?
Weight of 3, one step before is infinity. So it is infinity.
Yeah. We will consider this, right?
Yes.
We will take data from the previous column.
Hmm. Yes, ma'am.
Yeah. 5.
5.
7.
6. 6.
Now, how this 5 got 7?
Because again the minimum, so we have the updated weight of 1 as 5, then we will add the weight to 5 plus 2 7.
Oh, okay.
Okay, so we have to consider all the incoming edges, right? So what is the distance of 6? Maybe 9, right?
Yeah, remains same.
Yeah. So this is 8. Again in the next step we will do the same thing. So this will be 0, this will be 5. What is the weight of 2? Weight of 2, consider the 5, this edge.
5.
5. Yes, ma'am.
So whenever 3,
7.
7.
yeah. Okay, so 4,
13.
4. Okay, we have 7.
Yes, ma'am. 13.
Okay, then 5. Yeah, 5.
Ma'am, for 3 it should be 6 now.
Yes.
For 3 it should be 6.
6 plus 1, 7, bro. From 2, there is an
No.
outgoing edge.
We are taking this data na, from this column. We will take data from the previous column, right?
Yes, ma'am.
6 plus this one, so it will become 7. Now 4,
Mm-hmm.
we have to take the data from the previous. So again, we will take the distance of 3 as 11, then we will add 2, so it will become 13, right?
Yes, ma'am.
Yeah. So for 5, we will consider again 1 and 6, right? And the minimum one. 1 and 6, 9. So once we will get 8, and from here we will get maybe 5, 6, 7, right? So the 7 will be minimum, right? Is it fine? Then 9 and 8. Okay. Now the final step. So what is the final step? This is again 0. This is again 5, 2. What will be the distance of 2? 5, right?
5.
Yeah. 3.
6.
Yeah. 7, 4.
9.
5.
7.
6.
9.
And 7 will be 8, right?
8.
Very good. So this is the final column, okay? Because we had 7 vertices, so we repeated the process 6 times, n minus 1 times, okay? So this is the final column. If you do the step once again, then this column, the final column will be repeating after the 6th step, okay? If not, if you are getting something decreasing, that means there is a negative cycle in the graph. So we know that if there is a negative cycle in the graph, then we cannot calculate the shortest path, right? Okay, so that is, you can consider as a way, using that we can also check whether there is a negative negative cycle in the graph or not. Okay, so this is the process. This process is Bellman-Ford algorithm, and using this we can calculate the shortest distance from the source to any of the vertices, if also there are some negative weight present in the graph. Okay, so any doubt regarding the algorithm?
Ma'am, I got 4 will 8. 4 is 8.
4 as 8 means?
4 as the distance of 4 is 8, not 9. I got.
Will be 8 in next step.
The distance of 4 will be 8. Why? Why it is 8?
Because
Ma'am,
in this
I
step,
Distance of
got
7 is 7. 7, no? We have to use the previous column. So again we have 7 as distance of 3. Then we
okay.
will add 2, right? So it will become 9, right?
ma'am, he's saying that if we do one more time this sequence or this process, the distance of 4 will become 8.
Okay, if
6
you
plus,
do one more step.
yeah, he's saying that.
Okay, then maybe there is some negative cycle present in the graph.
Yes, ma'am.
So we have to check it if there is any negative cycle present in the graph. So if it is decreasing, then it will, like, you can conclude that there is a negative cycle present in the graph. Okay. So you can
Ma'am,
also,
we should not repeat more than n-1 times, right?
Yes, ma'am, there is a negative cycle 5 to 2, 2 to 7, 3, 3 to 4, and 4 to 5.
2 to 3, 3 to 4, and 4 to 5.
Yes.
This is not negative, right? This is 0 maybe.
Yes, sorry. It is 0. Yeah, sorry.
This is not negative. So because it is decreasing, that means there is some negative cycle. So can you see any negative cycle here?
Yes, ma'am. 6, 5, 2, 1.
6, 5, 2, 1. Then, like, if you are talking about a cycle, then you have to return to 6.
Oh, sorry, sir. Sorry.
Five two one five, I guess.
5 to
5215.
5 to 1, 5. This is 1, right?
Yes.
Okay, but we can check it later. Okay. Even after the class also, you can take it as your homework. You just try to check whether there is a negative cycle or not. Okay.
Okay.
Yeah, let us not waste time right now for this because we have to cover so many things today, right?
Excuse me, ma'am.
Okay.
Yes.
Ma'am, in the previous graph, while taking 5, the incoming edges will be 4, 1, and 6 now.
Yes, 4, 1, and 6, right?
Okay, ma'am.
Yeah. So we will consider all the incoming edges. Okay.
Yes, ma'am.
Okay. So we will try to find if there is a negative cycle in the graph or not. Okay. Later, not right now. Okay, so it was about finding the shortest distance of any vertex from a fixed source, right? Now we will consider the shortest distance between any two vertex. Okay. Okay. And the method what we will follow is called Warshall method. Okay. Warshall's method or Warshall's algorithm. Okay. So here we will introduce a new term called SPKij, and SPKij is the basically that means the ijth entry. This is a matrix. Okay. SPK is a matrix, and the ijth entry of the matrix is the shortest path from I to J via vertices 1, 2, k minus 1. Okay. So this is the definition of SPK. So SPK is a matrix for which the ijth entry of the matrix will be the shortest path from I to J via the matrix, via the vertices 0 to k minus 1. Okay, and this k basically varies from 1 to n plus 1, right? So we have, if we have n vertices, that means the cardinality of V, suppose n. So not n, yeah. So that means if we have n plus 1, n. So the vertices, set of all vertices, suppose 0, 1, 2, up to n minus 1. Okay, that means we have n vertices in the graph. Okay, is the definition clear?
Yes, ma'am.
Okay. Then what will be SPN? SPN, this will be the matrix whose ijth entry will be the shortest path from I to j via the vertices this, right? That means 0 to n minus 1. That means this is the all shortest path among all the possible paths, right? This is the final thing which we want, right? And what is n? This is the cardinality of V. That means set of all vertices or the number of vertices in the graph, right? Is the definition clear? If it is, then we will move towards the example. Is it clear?
Yes, ma'am.
Okay.
Ma'am,
And
can you repeat again?
yeah, sure.
Mm.
So here we will introduce a new matrix. The matrix we will denote the matrix as SPK. Okay. So K is the number of vertex which can vary from 0 to n. Okay, K can vary from, sorry, not 0 to n, K can vary from 1 to n. Okay, and how can we define the SPK matrix? Now this is the matrix for which the ijth entry of the matrix will be the shortest path from the vertex I to the vertex j via the vertices 0 to k minus 1. Okay, this is the definition. So because k varies from 0 to n, so we can find sp1, sp2 up to spn, right? So what will be sp0? sp0 ij, that means the ijth entry of the matrix sp0 is nothing but the weight matrix of the graph. Okay, the ijth entry of the sp0 matrix will be the weight of the edge ij. Okay, and if there is no edge from I to j, like if there doesn't exist any weight, any edge ij, then we will consider weight of ij as infinity. Okay, this is the definition. Now we will consider the previous graph one again, and we will calculate the matrices sp0 to some spk. Okay, if we once we follow our example, this will be more clear. So let us again draw the previous graph. So 0, 1, 3, 4, 5, 6, and 7, right? We had the screen is visible, no?
Yes.
Which algorithm, ma'am?
Warshall algorithm. So we will find the shortest distance between all the possible vertices. Okay. Here we don't have any source, so we will find the matrix. So it will be something like the adjacency matrix. Okay, it will be representing the shortest distance between all the edges. Okay. Okay, so this is our graph. We will first calculate SP0. Okay, let us first write all the vertices. So we have 0. Yeah,
Ma'am, 1 to 5.
1 to 5.
It's 2. Okay, sorry.
Yeah,
I
yeah,
think
it's 2.
I forget.
So this class will be little lengthy. Okay. Oh, I forgot to write 3. Tomorrow is the graded assignment deadline, na?
Yes.
Okay, so we have to cover
Yes,
all
ma'am.
the school. Yes.
Week 11 deadline.
Yeah, right. I know. So that's why we have to cover all your doubts today. So tomorrow class will be little lengthy. Okay. Not tomorrow, today's class. Sorry, what I'm saying. I know. Okay. So we listed all the vertices. Okay. So as we know, as per the definition, what is SP0? This is a weight matrix, right? So we will write the weight. Okay, and if there is no edge from the matrix to the corresponding matrix, then we will write 0. Okay, that means the no path connecting, sorry, not 0, infinity. That means if there is no path connecting those two matrices. Okay, so let us start filling. So what will be 0, 0? Infinity, right? So there is no edges from 0 to 0. So there is no incoming edge to 0. If I even want something to come 0, there should be some incoming edges to 0, right? Right?
Yes, ma'am. Yes, ma'am.
Yeah. So because there are no incoming edges to 0, that means there is no path from 0 to 0. So this will be infinity. Okay. 0, 1. This is clearly 10, right? We have direct. 0 to 2. So this is because from the definition, this is a weight matrix. We don't have any direct edge from 0 to 2. So this will be
Infinity.
Right? So we have only outgoing edges from 0 to 7 is 8. So rest of the vertices will be infinity, right?
Yes, ma'am.
Okay. Then 1, 0. Again, it will be infinity, right? Just let me know about the others. Like 1, 1.
1 to 5 is 2. The rest of all are infinity.
Yeah, right.
Leave them the dot infinity.
Yeah, we can write infinity also. No issue. Okay. What about the 2? Third column.
2, 2, 3, 1. Rest all dot. Infinity.
2, 3, 1 and rest are infinities. Yeah. Third column, fourth column.
No. 2 don't have any connection with 1.
2. From 2 to 1
Oh,
we
yeah. Sorry. Yeah.
Okay. From 3 we have outgoing edges to 4, right? So at
3 to
4
4.
this will be what? What is the edge? 1, right? And
3
rest.
to 4 is 3.
Oh, sorry, 3.
3
Yeah.
to 4 is 3.
3 to 4.
Rest all are infinity.
Yeah. Next.
4 to 5 is -1. Rest all are infinity.
Then
अब ग्राफ नहीं दिख रहा.
5 to 2 we have -2, right?
5 to.
And no outgoing edges. Other than that, that means rest of all will be infinity. Okay, 6. So from 6 we have outgoing edges to 1 and 5, right?
1 and 5.
So 1 is -4 and 5 is -1, right? Other
Yes.
way.
7 to 6 is 1.
7 to 6 is 1 and rest are infinity, right?
Yes.
So this is our SP0 matrix. That is the weight matrix. Okay. Now let us calculate SP1. So what will be SP1? That means if we follow the definition, SP1 will be, that means we will use K equals 1, right? So we have to consider the shortest path from I to J via the vertex 0, right? Right? As per the definition, 0 to K minus 1. Because we have K equals 1, that means we will have 0 and this is also 0, right? So we will have only one vertex, which is 0, right? That means we have to, yeah. So we have to fill the entries so that will represent the shortest path from I vertex to the J vertex via the vertex 0. Okay. That means we should have something like that. I to 0, then 0 to J. Is it possible for any cases? Is this case possible?
No.
Because we don't have any incoming edges to 0, right?
Yes, ma'am.
Yeah. So we will not find any extra path in SP1. So SP1 will be same as SP0, right? Okay. Then we will calculate SP2. So what is SP2? This is the again shortest
How
path.
ma'am? SP1 is equal to SP0, ma'am.
Okay. So SP1 means we will consider the direct edges and the vertices which passes through 0. That means this type of thing or this type of thing. Okay. That means the vertices which are connected through 0. Okay. But if you observe 0, then there is no incoming edges to 0, right? If I want to connect two vertices via 0, then there should be one incoming edge and one outgoing edge. At least one incoming edge and one outgoing edge, right? But there is no incoming edge to 0, right? So
Yes,
this type of path will not exist. That means we will only consider the direct paths. That means SP0 and SP1 will be same.
consider.
Okay. So when we will compute SP2, this will be the shortest path from I to J via the vertex 0 and 1, right? So this can be like I can be like 0 then J. This is one possible case, or this can be a possible case. I to 1 then J and the opposite. This is a possible case. And again like I to 0 then 0 to 1 then 1 to J, or the opposite one, right? These are all the possible cases, right?
Ma'am, then this algorithm will take ages to complete then.
Again, repeat please.
I mean, to completely solve, it will require ages of time then.
Yeah. Yes, this is little bit time taking. But yeah, you can just observe the graph and discuss some of the cases. Just for example, here you can discuss this case first because 0 doesn't have any incoming edge, right?
Yes, ma'am.
Similarly, you can discuss this case too, right? Right?
Yeah.
So we will only compute this case. That means we have to check the incoming and outgoing edges to 1. Okay. So 1 can connect 0 and 5, 4, 6 and 5 and 2 and 5 only, right? Because incoming edges are 0, 2 and 6 and outgoing edges is edge is 5, right?
Yes, ma'am.
So rest of the entries will be same. We will only update the entries 0, 5. So I will use a different color to here. So 0, 5 will be upgraded from infinity to, what is the age? 10 plus 2, 12, right? Then we will get 0, 2, 5 via 1. So this is 1 plus 2, that means 3. 2, 5, this is 3. And 6, 5, that means minus 4 plus 2, so minus 2. 6, 5. So again, we will take the minimum. So minus 2. Okay. Fine.
Yeah.
So yeah, white one is SP0, SP1, and if just rest of the entries will be same. And if you consider the red entries, then including them, this is our SP2. So similarly, we can calculate SP3, 4 up to SP6, 7, right? We can compute up to SP7. Okay, not 7, 8.
Yes.
Yeah, 8, because the cardinality of the set of all vertices is 8, right? 0 to 7. So we can compute up to SP 0 to 8. So this is the procedure. Okay. So is it clear how to compute these matrices?
We have to take some 2 points and then we have to see how much we can connect those.
Yeah. That means you have to consider points. You have to take the combination, which are the possible combinations. If you can discard some way, then you just discard and check the vertices, check the incoming and outgoing edges, then conclude. Okay. Fine.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Fine.
Okay. So we will next move to a new thing, new definition, you can say. You know what a tree is, right?
Yeah, ma'am.
So we also know some properties that if we add one edge to a tree, it will be a cycle, right? It will form a cycle, right?
Yeah.
And if we take back a edge, then it will be a disconnected graph, right?
Yes.
Okay. So these are the properties. Now we will know about spanning trees. Okay. So what a spanning tree is? Spanning tree is nothing but the tree which will contain all the vertices. Okay. Like which will connect all the vertices to each other. Okay. With the minimum, like with the all the properties of tree. Like if we just take back one edge, then it will be something disconnected, which is not a tree. And if we add one vertex, add one edge, then it will be it will form a cycle. Okay. So spanning tree is a tree that connects all the vertex. Okay.
Yes, ma'am.
Yeah. Okay. So the thing is, a tree is obviously acyclic, as you know. Okay. So if I just let us check one example. So if suppose we have 1, 2, 3, 4, 5 like that. Okay. Suppose this is our graph. So suppose we want to like compute the spanning tree. That means the edges which will contain the all the vertices, right? So we can take this edge, right? Then we can connect it with this. We can take this and this, right? So this will be a 2, 3, 4, 5. So this is a spanning tree, right? Right?
Yes, ma'am.
Can we consider another one like that, which will contain all the vertices? So we can also consider like that 1, 2, 2, 3, 4. Sorry. This what we already considered. So we can also consider this one, right? 5 and then 2, right? So
Yes.
both of them are spanning tree. So we can obviously then conclude one thing, that spanning tree is not unique. Okay. Okay. Both are spanning tree. So if I have a graph, we can like draw the spanning tree in so many ways. So spanning tree is never unique. Okay. Next, we have a problem to calculate the minimum cost spanning tree. Okay. So for that, we will use two different definitions. Two different process or algorithm. So next problem is, so what a minimum cost spanning tree is. So whenever we will get a graph, a weighted graph, so we will have some weight 1, weight 2, weight 3, weight 4 in the spanning tree, right? So if we add all the weight, then the added weight will be the weight of the tree. Okay. So as the spanning tree is not unique, so we can consider so many graph as the spanning tree. But among them, what is the graph which is of least weight? We can compute this graph. Okay. So this is the problem called calculating the minimum cost spanning tree. In short, we will call it MCST. Okay. So to solve this problem, we have two different algorithms. So first, we will run Prim's algorithm. Okay. So what our Prim's algorithm is, just I will write steps. So the step 1 is, we will consider TV and TE. Okay. So TV is tree vertices, set of all tree vertices. And this is tree edges. Okay. Clearly, the TV is a subset of B and TE is a subset of E, right? Because the vertices of the tree will be taken from the vertices of the main graph, right? And the edges are also taken from the vertices edges of the main graph, right? So the TV is subset of V and T is subset of E. Okay. So we will initialize TV and TE both equals to 5. Okay. Then whenever we will start with the edge which has minimum weight. Okay. Step 2. This is our step 2. Okay, we will choose the edge which has the least weight. Okay, if you have two edges with the same least weight, then you can pick one of them, any one of them. Okay, so suppose the edge is ij. Okay, suppose this is the edge ij. Then immediately we will take the vertices I and j in the set of TV and the edge ij in the set of TE. Okay, then we will consider a new edge, a new vertex k, which is not in TV. Okay, and there is a edge from I to k or j to k with least weight.
K is our assumption. It doesn't exist yet.
No, k is not assumption. Like k is a vertex, okay, which is not in the tree vertex. I mean, which is not equals to I or j. Like k is another vertex from the set.
Okay.
Okay, k belongs to this
Yeah.
set. Okay.
K belongs to set, but not in the tree.
Yeah, right. K belongs to the set, but not in the tree. And there should be a edge connecting any one point from the TV to the vertex K. Okay. So then we will consider the least, the vertex which has least weight. And then again, we will add K to our TV. Add K to our TV. And the new edge, this one of this edge in the TE. Okay. Okay, is the step clear? Now we will solve an example. Okay, and also we have to keep it in our mind that this if I add this should not form any cycle, because in a tree tree is a acyclic graph, right? So this, if I add some edge, this should not create any cycle, form any cycle in the edge. Okay.
So we are taking two vertexes, introducing third one, which connects either of them and adding it to the tree.
Yes, right. Then again we will introduce the fourth, fifth and sixth until the end. Okay. Yeah.
Yes,
So this is the process. Okay. Let us now just solve. So we will start with the previous example. So the example was. Okay, so this is our example. Okay, now our TV and TE both are 5, right? This is the initial step. So both are 5. Now in the next step, we have to choose the edge with least weight, right? This is the step 1. Step 1 is done. Okay, step 2, we will choose the edge with least weight. Okay, so what is the updated TV then?
This is 1, 3, 1.
Yeah. And TE will be the edge 1, 3, right? 1, 3. So that means we have this. Okay. Then we have, how many options are there now? Like the edges which are connected to 1 or 3. So 0 is connected to both 1 and 3. 4 is connected to 3. 2 is connected to 1, right? So we have these 3 options. Now we will choose an option which has least weight first. Least weight. And second, will not form a cycle. will not form a cycle. Okay, so we have this. So what is the age we have to consider?
1, 0.
We will not take 0, we will take 4 and 2.
So now our updated TV will become 1, 3, then 0, and TE become.
We won't take 0 now because it's making cycle.
No, but we don't have this age now. What 0, 3? We are taking this age only.
0,
Right?
3 is there.
0, 3 is not there, no? So this is not making a cycle until I take 0, 3 in the set of. If I take
Okay.
0, 3 in the set, then it will make a cycle, right?
Yeah.
So these are the updated vertex. Now again we have 1, 3 and 0. So we will consider again 2. So we have in our options 2, 4, right? These are the only left options. So we will consider 2 because of the least weight, right?
Yes.
Yes, ma'am.
Yeah.
And then 4.
Yeah.
2 to 4.
That means this. That means first this and then this, right?
Yes, ma'am.
So
Yeah.
this is for 2, then 4. Okay. So this become our minimum cost spanning tree. Okay. Okay. So this is the procedure. This is quite simple. Just have to keep these 2, 3 things in your mind. So you have to add gradually. You have to start with the least weighted edge. Then you have to gradually grow the tree with with some edges which has least weight and which will not create a cycle. Okay. Is it clear?
Yes, ma'am.
Okay. Okay. So once.
Could you please repeat it once again?
Okay. So in this Prim's algorithm, you have to start with a age which has least weight. Okay. So we started with 6 because 6 has least weight in all over the, like among all the weighted in the graph, right? Then you have to grow the tree in such a way like with some new edges which has least weight, which will not create any cycle, and which is connected to the vertices which we already have taken in the set of all tree vertex. Okay. Okay.
Yeah, ma'am. Yeah.
Okay. Very good. Okay. Then this is the last algorithm we have to learn. Kruskal algorithm. Okay. So this is again another simple algorithm. So the step 1 is first you have to note all the vertices. Okay. Note all the vertices. Step 2 is then just list all the edges in ascending order of the with respect to the weight. Okay. Step 3, you have to discard the edges which are forming cycle. Okay. This method is the most simplest method as according to me.
This and Prim's as well. Both are.
Yeah. Prim's method is also a easy method. Okay. Okay. So let us solve one example using this. So again, let us do the same example. Okay, we will let us do it here. We will use another color so that you can get the difference. Okay. So we have to note all the vertices. So this is basically 1 to 4, 0 to 4, right? 0 to 4, all the vertices. Right? Then we will note the edges in TE. This is in the ascending order, right? Okay. So yeah, any one of you can unmute yourself and just tell me the edges in ascending order.
1, 2, 3.
Yeah, 1, 3, then
2, 4.
yeah, then
0, 1. And then 1, 2.
1, no, 0, 1. We will like list all the edges in that ascending order. Okay.
Okay. We have
So
to, okay.
first we will list all the edges. Okay. So this after this we will take 0, 3, right? After 10 we have
Yeah.
next. Then 1, 2,
1,
then,
2,
then 3, 4, right?
Yes.
So this is the first step. We have to list all the edges in ascending order. Okay. Now we will check all the. What happened? Can you hear me?
Yes, ma'am.
Okay. Now we will check one by one all the edges. I mean, we will scan our T vertex set and then we will discard the edges which are forming cycles. Okay. So the first edge is this. So we don't have any problem with this, right? Okay. The second is 2, 4. So this is again not forming a cycle. Third is this. Fourth is this one, right? Which is forming a cycle. So we have problem with that. So we will discard it. Okay.
Yes. Yes, ma'am.
Yeah. And the fifth one is this. Again, this is not forming a cycle, but this is forming a cycle. So we will discard this, right? So that means this 4 vertices will be the set. Okay. So just if I just draw the red pen, this is the, sorry, not this, this. This is the least cost spanning tree, right? So you can verify. We worked on a same example with both the method, and we arrived to the same. We arrived to the same tree, right? So the least cost spanning tree will be same. This will be unique. We can use any of the methods. Okay, so if you have any doubt, just let me know. Then we will start solving some problem.
Hello, ma'am.
Yeah.
Yeah, how to calculate maximum number of spanning tree in a graph?
Maximum number of spanning tree means?
Yeah, possible number of spanning tree. Because there is a question in activity.
Possible number of spanning tree.
Yeah. Can I give the number of that question?
Yeah, you can just, I mean, scan the graph. I mean, I don't remember any specific formula to calculate possible number of spanning tree. But if you just scan the graph, then you can form the tree, right? So you are finding, if you are finding some number of tree, then just enlist the number. I mean, this should be the way.
Yeah, ma'am. But I solved in the activity question. So as per the drawing trees, so I came up to 6 number. Total number of maximum trees is 6, but the answer was 16.
16.
Yeah.
Okay. So, okay, I will check the question once again. Then I will.
Okay, ma'am. Okay.
Yeah.
Thank you.
Okay. Any other doubt? No, right? If yes, just let me know. Then we will go to the solve with us portion. I mean, there are some selected problems. We will just solve them, so that we can just recall all the methods together. Okay, so silence means I'm taking it as positive sign. So okay, I will just quickly go through the problems so that we can just cover them, and then I will pick your doubts. Okay. So this is the first question. We have to use Discard's algorithm. Just take 2 minutes time to solve this and let me know the answer. Once you solve the problem, just unmute yourself and tell me the answer. Okay, I will not able to see the chat box. So just unmuting yourself, you can tell the answer. Just try to apply the Discard's algorithm. Hope you remember the algorithm, right? Or else any one of you can unmute yourself and just briefly describe the algorithm.
It can be 1 to 7.
1 to 7.
Yes.
1 to 7 or 1 to 6.
Ma'am, I think 1 to 5. Okay.
Okay, let us check.
It's
So what?
less than 7.
Yes.
Yeah, it is less than 7.
Yeah.
Yes.
Right.
It's less than 7.
That means 1 to 6.
Yes.
Yeah. So clearly, we want to find the shortest distance from A to 7. J. This. That means we will follow this path, the minimum, then again the minimum. Then we have two different choices.
2, 6, where 2 is minimum.
So no. We cannot take this because this will form a cycle. So we want to take this route. So we can take this route, then this route, then this route, then this route, right? So if we take this way, then again this portion of the route is same, right? Only the difference is for this way. That means, and the distance, I mean the total distance of this path is 4 plus 3, that means 7. So if this distance is less than 7, then we can consider this path to be the shortest path, right? So we will consider something which is less than 7. Okay. Okay.
Yes.
Okay. These are the printed solution. I guess you also have the PDFs, right? So if you want to check them, so you can go through the solutions. Okay. So this is a question 2. This is a question. Again, yeah, take your time to solve and just let me know the answer.
Five.
So if we just follow the rule, 5 means we have to like take it 5,000. Any other
Yeah.
answer? Any other?
I'm calculating first as C1, then C2, then C3. Sorry.
So you have to go to C0 to C3. I mean,
Yeah, okay.
C0, C1, C2, C3, C4. Similarly, C0, C1, C2, C3, C4. So if you have the matrix,
Then it is also 5.
okay. So I'm taking your answer as 5. So is there any other answer, or we will, or I can proceed to solve? Okay. So if I have a matrix, I can draw the graph from the matrix, right? So we have the vertices C0, C1, C2, C3, and C4, right? So C0 to C0, there is no vertex, obviously. From C0 to C1, wait, from C0 to C1, we have this of weight 2, right? Then C0 to C2, we have no direct edge. Like we don't have anything direct from C0 to C2 because of infinity. Okay, indicate there are no direct line. Okay. Again C0 to C3 infinity, that means there are no direct edge from C0 to C3. C0 to C4, there is a direct edge with the weight 5. Okay, so like that we can draw the graph. Maybe the graph is, yeah, the graph is here, so you can check. Just match, let us match the matrix with the graph. Okay,
6.
okay, 6. Okay, so we have answer 5, we have answer 6. Okay, so this is the graph. So I guess you don't have any doubt about the graph, right? So if I have the adjacency matrix given for a weighted graph, then we can draw the graph, right? We just have to draw the edges and just put the weightage on the edges, right? So we can draw the graph, right? Okay, so the next problem is we have to reach from C0 to C3. That means the cheapest route. That means we have to find the shortest route from C0 to C3. Okay, so we will start from C0. We will choose the list, right? Then again we have these two options. So we will choose the list again.
Right.
Again we have this
That-
two
that's right.
option. So we will choose to
Six. List.
okay,
That's
so
right.
we have this path C0, C1, C2, C4, and
See.
this is, yeah, 2 plus 3 plus 1, which is 6. So
Yes.
6 is the answer. Okay, so once 6 is the answer, that means if I follow, so the answer is 6,000. Okay, so just these are the detailed solution. So the answer is 6,000. Any doubt?
No, ma'am.
Okay. This is the next question. Again, take your time to solve it and let me know the answer. Did you find anything? We have to check the root, right? So again, you have to consider the graph. The graph is given here, right? So this is the graph, right? So we have to calculate the shortest route, which will cover all the vertices and which will start from C0 and end at C3. Okay. Okay. So yeah, any answer? Hint is like you have to consider all possible way, covering all the vertices starting at C0 ending at C3, and then just calculate the cost and choose the way with minimum cost. This is the hint, and let me know.
C0, C1, C2, C3.
C0, C1, C2, C3. Okay, you have to cover all the vertices.
Yes.
Okay, all the vertices.
Yeah. So we have to also cover C4. And C3 should be the what?
I think 20.
Hmm?
C0 to C1, C1 to C2, C2 to C4, and
C4, C4 to C3.
Okay. This is the answer, right? Okay. So we want to compute.
ma'am, I think it is like traveling salesman problem.
Yeah. Yes. 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 Okay. So what is our problem? Now we have to cover all the vertices, and this is our starting point and this is our destination. I mean, this is the ending point, right? So what is the possible way we will check? So we can go through this and this. Then we can not choose this because we want C3 to be the end point, right? So then this and then this. Okay. So this is one possible way. That means this one, which you have told me. So then the second way is also possible. So we can come here, first C4. Then we can go to C2. Then we can go to C1 and then we can go to C3, right? These are the only possible ways, right? C0, then C4, then C2, then C1, then C3. These are the only possible way, right? Now we will calculate the cost. So what is the cost for the red line? 2 plus 3 plus 5 plus 10, right? That means 20. And what is the cost for the blue line?
21.
21.
So obviously we will choose the way which can cause the least price, right? That means the red line. So yeah, your answer is the correct one. Yeah. So you can go through the solution also. So this is the way how we can solve them. Okay. Then we will use Bellman-Ford algorithm to solve the problem. Yeah. So this is the next problem. Just analyze the graph and let us consider some.
X should be greater than -7.
It should be greater than -7.
Greater than or equal to also.
Okay, but we don't have any close bracket, so we will take just greater than. Okay?
Ma'am, this is also an activity question. There is a question that why we don't include 7 in our range.
Why we
This
don't?
slide uploaded, no, ma'am?
Don't include.
This
Excuse me.
slide. What?
Hello.
Yes.
I am audible.
Yeah. Yes, you are audible.
Hello.
Yeah, you are audible. Hello.
Okay, so why we don't include 7 in our range? Like we don't get any negative cycle. It becomes 0. So yeah. I also asked this question to a TA. He said that option is wrong. We should include 7 in our -7 in our range.
No, I mean, like if because in the options we only have open, so we can consider this. So there is no problem in that. But if there were 7, then there should not be any problem. Like it seems to be like that.
Excuse me, ma'am.
Yeah.
This slide uploaded.
This solve with the slide.
This solve with the week 11 slide. This.
Yeah. You can find this in the supplementary content maybe.
Okay.
So, ma'am, I have a doubt. Like you said that -7 to infinity, it is correct. Yeah.
Yeah, we can include -7.
So if we put x is equal to -6.5, so what is the distance between 0 to 4? 6 plus -6.5, it should be -0.5. Huh? And distance is not negative. 0 to 4. 4, yeah.
No. See, distance here we are like measuring the distance. We are saying a distance, but it can be something else. No, I mean because the weight can represent anything. We don't know. I mean, whenever we use some -1, this is also a distance, right?
Yes.
So this can be negative. This is not the usual distance. So this distance can represent something else, which can be negative. So no problem with the negative distance.
Okay.
But yeah, we can include -7. So if I include -7, this graph is not forming any negative cycle. So we can include -7, but because in the options there are no -7, so we will take the open intervals. Okay.
Okay, got it, ma'am. Because of this, I think that 0 cannot be included in this. That's
What 0?
I think that 0 is also not permitted to include. And that's why I've asked this question to TA, and he said that no problem. We can
No, we
include some
can include 0. We cannot include minus something.
Yeah, minus negatives.
Yeah.
Negative side.
Yeah, negative something. But we don't have any problem with 0. Yes. So we have a problem with negative cycle. So if this is something like...
Can you explain once again?
Yes, sure. So as we know that if we have a negative cycle in our graph, then we cannot find the shortest distance, right? So if x is something less than -7, then this will form this cycle will form a negative cycle, right? So we have to take something greater equals to -7, right? So if I take this range, that means this is the feasible answer. Okay. We can also include 7, but because there are no, I mean, in the option, they didn't included the 0.7, so we will not include. Okay.
Yes, ma'am. Got it.
Yeah. Okay. Any doubt? No, right? Okay. Then we can move to the next problem. Okay. This is example. This is the problem. Okay, they have solved it using the whole method. So this is the, yeah. Okay, this is an example, and you need to perform the method. I mean the Bellman-Ford method up to 3 steps. Okay, so we just solved this thing, and we know how to like calculate the distance using Bellman method, right? So we have to just calculate up to the 3rd step. Okay, so up to the 3rd step, 1, 2, and 3. So this is what you can do by yourself, right?
Yes, ma'am.
Yeah, if everyone is okay with it, then I can skip the problem, because yeah, there is no meaning to waste the time, right? So if everyone is okay with it, then I will skip the problem. It's fine.
Okay, ma'am.
Right, these methods we are just finding out the smallest path possible, now.
Yes, yes. So
So
to find the the accurate smallest path, we have to like repeat the step up to the 7th path, right? I mean the up to the 7th step, right?
yes, ma'am.
But in the
So
problem, they have asked to do up to 3 paths, like 3 steps. Okay, that is why we have to calculate up to 3rd step. Yeah, you were asking something.
then this question really excluded the thing that I thought about. I thought about to make. I mean, there are a lot of algorithms that we have just studied. So any one which is very fast, easy, and cheap time consuming to find out the shortest distances for the all vertices. We don't have such now. We have to go with this all.
Yeah, actually. So they are actually little bit time consuming. You have to observe the vertices, then you have to put the entries.
Yes. Yes, ma'am.
So I'm skipping the problem, okay? So you can do that. Okay, this is the next problem. So again, we have the same graph. Here they calculated up to the 3rd step. And now in this question, they have asked the value of D3, D4, D5. That means the distance of 3, 4 and 5. Okay. So for that, we have to calculate up to the 7th step. Okay. So you can check. This is the 7th step, right? 1, 2, 3, 4, 5, 6. I mean, if you include the initial step, then this is the 7th step. The number of vertices is 7. So this is the n, and we will repeat the step up to n-1 time. That means 6 times. So up to 6 times, if we repeat the step, we'll get this column. And as I said, if we repeat the step once again, then we will get the same column. Okay, and this is the final answer. That means this is the shortest distance. Okay. Okay, so you can calculate the table and you can find the shortest distance. And in the question, they have asked to find the shortest distance for 3, 4, and 5. So for 3, the shortest distance is 5. For 4, this is 2. And for 5, this is 1. Okay.
Yes, ma'am.
Okay. So yeah, I just request you have the PDF, right? So you just take the PDF and
Just once explain how the option will be.
yes.
Just once explain this algorithm.
This one. Okay. So as I said, you have to initialize the step with this. I mean, the source, the distance of the source will be 0 and the other vertices will be infinity initially. Okay. Then you have to update the distance of all the vertices and the what is it called? The formula to update this is like you have to take the minimum distance. I mean, distance of k is the minimum distance of k in the previous column and distance of j plus weight of j comma k. Okay, where j is such a vertex such that there is a edge from j to k. We will consider this type of vertex such that there is a edge from j to k. Okay, just for example, if I suppose I want to calculate the distance of 1, okay, in the next step. So in the next step, the distance of 1 will be minimum of distance of k, that means distance of 1, and distance of j, that means we will consider the incoming edges, right? So we can see only one incoming edge is there, which is 0. So distance of 0 plus the weight of the edge 0 comma 1. Okay, so in the the data we will collect from the previous column. Okay, so in the previous column the distance of 1 is infinity, so we will take infinity, and the distance of 0 is 0. So this will be 0 plus the weight is 10. Okay, 0 plus 10. That means we have to take the minimum between infinity and 10, which is 10, right?
Yes,
So, yeah. So in the next step, we will update the weight as 10. Okay. Similarly, we can calculate all the distance, I mean, distance for all the vertices. And then again, in the next step, we will repeat the same thing. So for the second step, we will take the data from the from this column. Okay, that means the immediate previous column. Okay, then we can calculate all the distance and we will repeat the process up to n minus 1 time, where n is the number of vertices. Okay, then we can arrive to the final answer. Okay. Yeah, if
Yes,
you
ma'am.
have any doubt, you can ask. Anything? Okay, so if you are silent, then the silence I will consider as positive sign. That means no doubt. So we will move to the next. Okay, this is another question.
Ma'am, those
Ma'am, 4 hours
those
continue classes. 2 hours statics, 2 hour mathematics.
Okay, so you had a stat class before this.
Yeah, 6 to 8.
Okay, it's becoming hectic for you also. Yeah, I can understand. But yeah, tomorrow is your graded assignment solution submission date, right? So we have to cover this also, right?
Yes, ma'am.
Yeah. Any doubt? Yes, someone was asking something.
Ma'am, those infinity represents what? They are infinite.
Infinity, it means, I mean, here in the first step, the infinity is nothing. I mean, it is just a process of initialization. In the second step, there is infinity. That means there is no direct edge from the source to the particular vertex. Okay.
We'll be taking the minimum now.
Yeah.
Got it.
Yeah. Okay. Any other? Anything else?
No.
Okay.
Proceed.
Yeah, okay. So we can proceed. And this example is again, you have the graph given and you have to calculate SP0, and we know that SP0 is the weight graph, right? So we have to choose the, we have to put the weight, and if there is no direct edge, then we have to use infinity at that place, right? So do I need to do that, or you can calculate it by your own? I guess you can do it.
Yes, ma'am.
Okay. So yeah, this is the answer. They have calculated this. So you can also calculate it by your own. Again, this is the question. You have to calculate the SP3. Once SP3 means 0 to n minus 2, right? That means 0, 1, 2. Okay. So if I want to calculate the ijth entry, so we have to consider all the paths for, which is via 0, or which is via 1, or which is via 2, or 0, 1, 1, 2, or 0, 2, or all the 3. So we have to consider all the cases. Okay. Then we can only compute the matrix. Okay. So again, I'm leaving these things to you. So SP3, SP4, and SP5. So they have described the method. Okay. So SP5. Okay. So you have to calculate. This is the given graph, and you have to calculate SP3, SP4, and SP5. Okay. If every one of you is agree with it, then I can skip the problem and you can solve it by your own. Is it okay for all of you?
Yeah, ma'am, skip. We'll try first.
Yeah, you can try them, because this is nothing but calculation and it will take so much of time actually. That is what I want to skip it.
I was thinking about some legendary stuff, making my own algorithm that will be less time consuming.
So what is the algorithm?
I am thinking about it.
Okay. Okay, you continue thinking. Okay. So we just learned about Prim's algorithm. So in this problem we have to use Prim's algorithm. Yeah. Let me know the answer. We just learned about Prim's algorithm, right? So you have the question and let me know the answer. So in Prim's algorithm, we need to first draw the graph from the adjacency matrix, and then we will start from the vertex with the least weight, right? Then we will gradually grow our tree with adding some edges which has least weight and which is not forming any cycle, and which is added to the vertex we have already collected. Okay, so these are the process of Prim's algorithm, and this is the adjacency matrix. Now we just calculate and let me know the answer. So, any answer? Are you solving the question?
Yes, ma'am. Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, okay. Then I am waiting. Okay. Starting with vertex R means we will start this vertex. Okay, then we have to grow our tree. We just have to give me this set. So the first step is you have to draw the graph, right? Have you drawn the graph?
Yes, ma'am.
Okay. Then
It
did
is
you find
too
the
much
TV?
complicated. It is. Spider-Man का है भाई ये तो.
So this is the graph, right? Is the graph same as yours? Is the graph same as yours?
Something different.
Yes, ma'am.
Same, right?
Ma'am, is it RUVPQSG? RUVPQSG.
Okay, so this is the set you found. Okay, okay. Let us start. Okay. So we have to initialize with R. That means this, right? So what is Prim's algorithm? We have to calculate our TV. So the first is we will consider the edge with least weight, right? And 1 is the least weight. So the first is R and second is U. This is clear, right? So we are done with R. We are done with U. Now we have to check the vertices, not vertex, which are particularly in this case, there is one, but there may be some cases, there may be more than one, but yeah, here, which is connected with any one of this. And then we will take one vertex which has the least weight, right? So we have only one option, which is V. So we have to visit V next with this edge, right? So in the next step, we will consider V. Again, we have only one option because we cannot take this as it is forming a cycle. So we have to follow this, right? Then P. Okay. So as far our path is like that, Then as we are in P, now we have to check the vertices which are connected with any one of these RUVP. So we cannot take RUV because there are no vertices between, like, among S, T and Q which are connected to R, U and V. So we will take P, and then we have two choices, right? One, we can go to Q. The second, we can go to T. So again, as per the rule, we will take the minimum weight. So we will go this way, and then we will enlist Q. Okay, so this is a visited. So we will write Q. Then we have only one option. So we have to go to S. Then we will take S. Then we will go to T and we will take T. Okay. Then we will not consider this because it will form a cycle. Okay, and this is the order. Yeah, this is correct. Okay. Any doubt?
Hello, ma'am.
Yeah.
Ma'am,
No, ma'am.
in this case, ma'am, the shortest distance of between P to T is 9.
Between
So
P to
T is 9. Because
yes.
if we are going through PQ
Yes.
ST, then it will be the longest path.
Yeah. Yes. P to T is 9. 9 is the shortest distance. Yes.
Yeah, ma'am. So in that case, we have to after Q we have to add T and S,
No,
not S and T.
No, here we are taking R as the source. Then we are growing the tree. This is not the problem to find the shortest distance from P to T, na? So here we have to take the R, and then we have to grow the tree, and we have to calculate the overall, the overall weight of the tree. And the overall weight should be the minimum. Did you get my point, or should I repeat it?
Ma'am, not getting why we are not able to connect
Okay.
P to direct T and S. Yeah.
I'm just repeating it. That means actually using Prim method, what can we say? We can compute the least, the spanning tree which has least weight, right? The minimum cost spanning tree means we will consider the spanning tree. Then we will add all the weightage. Then the added weight should be least.
Extended for this.
Yeah.
It's getting 36 if we go with the 9th
Yeah.
weight 9 path, and it's 20 something without
Yeah.
it.
So this is the maximum. This will not be minimum if I choose this way, this edge. Okay. That is why we cannot take this weight. Because here our aim is to find the spanning tree which has the minimum cost. Now, did you get the point? If not, then you can ask. I will again explain it. If yes, then yeah, let me know.
But it is possible to, ma'am, do the branching from P.
Yeah.
When we have the branch, we as we have connectivity between P and Q, then instead of going further to S, is it possible to,
No, this is not possible because the first step is you have to start growing the tree with the minimum weight age. So the minimum weighted age is 1, right? So you have to choose any one of Q or R as the starting point. What was the first step is you have to first choose the age with minimum weight, right? And if we choose the age, we don't have any other option. We have to start with this age which has the minimum weight. Then we have option between two vertices U and R. You can pick U first, you can also pick R first. That's why they specifically told you to took R first, so that we cannot we may not get confused with UR or RU. Okay, is it fine now? We cannot start with this because this is the maximum weight, right? So we have to start with the minimum weight. Okay.
Yes.
So if you don't have any doubt, then we can proceed to the next problem. This is the solution. If you want, you can go through the solution. Yeah. Now this is the most easiest method, Kruskal method. We have to use the Kruskal method, and this is the problem. Now take your time and you have the graph right now, so you can do it more easily, more fastly. This is the graph, right? I cannot hear you. Maybe you got muted, so you can unmute yourself again.
Sorry. It wasn't me.
Okay. So this is a question. Yeah. Like they need us, they need to like calculate the TE. That means the tree edges set, the set of all tree edges. Okay. This is the graph. You have to calculate TE. Okay, shall I once brief the Kruskal method?
Yes, ma'am.
Okay. So in Kruskal method, you first have to note all the vertices. Then you have to then secondly, you have to note the edges in the ascending order with respect to the weight. Okay, that means here you have 1, then 2, then 3, then so on. Okay, in the ascending order, you have to note the edges. Okay, the third step is you have to then scan the set. You noted the edges, right? So it will form a set. Then you have to scan the set and you have to discard the edges which are forming cycles. And if you discard the edges, then the remaining set will be your TE. Okay, so we can do it. Yes.
It's 8, 2, 9, and 6. There's many things that we can remove. I mean, we can remove like 8 and 6 to remove the cycling.
Okay, so we will always do it step by step to avoid the confusions. Okay, so first we will consider this. Okay, that means UR. Then what is the second? Because we are considering ascending order.
Yes.
So we will then take ST. Then third, right? RV. Then fourth. What is the fourth weight? 5, right? This one. Right? 4 is not there. So 5 will be the next, which is U, V.
Cycle.
But this is creating a cycle. So we will remove them.
Remove it.
Yeah, we will remove it. Then after 5, what is the next term? 6,
PQ.
right?
Yes.
PQ. Then 7.
Then EV. Yeah.
Then 8, right?
Yes.
That means QS. Then PT, but it is forming a cycle.
Yeah.
So it will discard it, right? So this is our next new set. UR, ST, RV, PQ, PV, QS. That's it. Okay. We will always move step by step. We will consider all the edges in order to the ascending order of weight. Then we will just discard the edges which are forming a cycle. Okay. Then yeah, this is our answer and this is their answer. Okay. Any doubt?
Wow.
No, ma'am.
So, ma'am,
Maybe this question, last question, no?
Maybe this should be because the method is last method. This is the last question here.
Yeah.
Okay, so we are done with you. Solve with us portion. Now, if you have any doubt from the activity or practice assignment, then let me know. Anything?
okay, ma'am. Thank you, ma'am.
So if you have any doubt, you can ask. Otherwise, we can end also. If you don't have any doubt. Any doubt?
Yes,
No, ma'am.
ma'am.
Peter, no doubt.
I've sent a question. Thank you. Just wait.
Practice assignment 11, last question. Aditya, are you there? Are you there in the meet? No? Is there anyone having a problem with a practice assignment 11th question?
I have also sent a question. Yeah.
It's taking some time to load. Okay.
So my question is, first we'll remove A.
Yeah. So what is what they want us to do?
Say you have to do 10 tasks and
The vertices are representing the tasks, right?
yes.
And the edges are representing the dependency of the task, right?
Yes, ma'am.
Okay.
It is like topological order.
Okay.
So my question is, first we'll remove A. It is correct. Then E, then B. They are also correct. But why don't we remove H after them?
H.
Yeah, H. We'll remove it in last. We remove C, then D, which are dependent on B, C, but don't H. H in last. Why?
Okay, this is maybe this is to solve this you have to use the DFS method, right? If I'm not wrong. I mean, you have to.
Ma'am, I think in this one, the H is also leading for level 2 exploration of the graph. So, and other points like HC and other points that we have, they are just level 1. So maybe because of this.
This is level 0, like.
Yes, ma'am.
Yeah, ma'am, level wise.
Yeah. Then we have this. No, not this.
Not Z, ma'am.
Yeah, not C.
Yes, not C. B and E.
This are the one, right?
Yes.
We cannot take B also. This is the second level. And in the third level, as these two are completed, so we can include H, we can include C. Right?
Yes, ma'am.
We cannot take G because G is dependent on H.
Oh, right. Thank you. Right. So this is the second layer, right?
Yes, yes, ma'am.
And
And the third is H and C.
yeah, so for H we need A, E, B, and yeah, H and C. This is the third. Fourth is G, D. That's it, right?
Yes.
Then we can use F. F,
And I also.
I. Then in the last step we will use J.
J. Yes. But
Just
look at answer.
okay. So A, then in the okay, let us just do the numbering. If it is 0, this is 1, this is 2, this is 3, 4. So A, then B is fine. Then in the third, okay, then E is fine. Then we can take C, the second step. Then okay, then we can take D. Then we can take F. So the H should be here, right? I mean,
Yes, yes, ma'am. We are not doing DFS in it. If you're doing DFS, then
it should be here, yeah, right. So for topological sorting, you can just consider the layering also. I mean the dependency, according to the dependency. Okay, after D, they have listed F, then I. Where is I? So this is not in order. I mean, I and F are same level, so we can use this I, F, and A5. So no problem in this, I guess. Then G. Okay, this is wrong because they have used G before H, but this is not possible, na?
Yes.
Right?
Yes, ma'am.
So you have to always take H before G because G is dependent on H. This is the problem here. Is it fine now?
Yes, ma'am. So 2 questions of topological ordering of PYQs are wrong.
This is wrong. Why? I mean, the option is
Because
wrong.
yes, option is wrong. Yes, ma'am. Option
Yeah,
is wrong.
yes. I thought the question is wrong. The
Oh,
question is right. The
but
option is wrong.
a question is also wrong that I sent at the starting of the class. DAG is not
explain once again,
possible.
madam.
Yeah,
Topological
that
ordering is not
question.
possible.
That question is wrong because this
Yes.
was not a DAG.
Yes, ma'am.
Madam,
This was not a DAG, but in this the option is wrong.
Yeah.
Excuse
madam,
me,
explain
ma'am.
once again.
One by one, please.
I have sent it this. Can you please explain the question?
This question. Can you send which one?
Yeah, 53.
This
Madam,
one.
explain once again, madam. The before algorithm.
Which one? Which one you need to explain?
Before, madam. You told before, no.
The last
order.
question.
Last question.
Okay.
Topological sort.
The third option is wrong. This option is wrong because here they use G before H, but G is dependent on H, na? So we should always keep H before G. That is why the option is wrong. Okay. Is it clear?
Second option is correct.
Yeah, the second option is okay.
But why? Why don't we put we pick H before D and I?
Because we can take this because D and I, these two are not dependent on H, na?
Yes, it is not dependent on H, but H is not.
Yeah,
H is
G
also
is
not
No, no,
dependent
no,
on
no.
yeah, G is as
See, see.
in degree, so it has H level.
No, no, the thing is, if H is not dependent on G and I, then we can take H later. But yeah, this is what we can do, but we cannot do this thing.
Okay.
But ma'am, in topological order, we have to thought that we remove the vertices level by level.
Okay. So you are saying about this, but this is what you are saying. It's a particular method, right?
Yes.
Maybe DFS method, right?
Not DFS, ma'am. Topological
Yeah,
ordering.
no, I don't remember the method name, but in particular method, we were considering the in degrees and then we were removing the vertices. But topological ordering means you can take a sequence like which you can take the point such that the later vertex, like the previous vertex, should not depend on the later vertex.
Yes. These
So
two, if we look like this, that D is not dependent on H and I is not dependent on H.
so
So
that,
these two options are correct, yeah.
yeah.
But I think that this is based on topological ordering and we remove the vertices level by level, so that that's
No,
why.
no. See, in the question they have asked you which of the following sequence may represent the possible order, so
Yeah.
that Shreya can perform the task. So if the previous task is not dependent on the later task, then you can do the task
Can
earlier,
remove.
right?
Yes, yes. So it is correct.
Yeah,
The both.
in that sense, it is correct. I mean, you have to just follow what they have asked, right?
Yes, yes.
So
So,
here for this type of thing, now just you have to consider the layerings. I mean, if the layerings is before, I mean the
yes.
less, then you can consider it earlier. No problem then. Okay.
Okay, okay, ma'am.
Any other doubt?
Ma'am, can you explain again Warshall algorithm?
Warshall algorithm. You was in the class during that time.
Yes, ma'am.
Okay, so what is your doubt?
Ma'am, in this, I am not able to understand how we are considering the vertices. It is considering from 1 to n or 1 or 0 to k minus 1.
Okay, so we have to consider all the vertices and all the possible paths. I mean, okay, just let us. This was the Warshall algorithm, right? So when we were calculating SP2, that means our K was equals to 2, right? So the points, the possible vertices were 0, 1, 0 and 1, right? So then we have to consider all the possible way. That means first this can be one possible way. The edges which are connected through 0, this can be one possible way. The edges which are connecting through 1, and this is one possible way which are connecting through both 0 and 1. Okay. So you have to consider all the paths. I mean, all the possible combinations. You have to choose all the possible combinations. Okay.
Yes, ma'am. Ma'am, can you scroll up? Ma'am, here what is the meaning of k belongs to 1 to n and this bracket 0, 1 and k minus 1?
Okay. That means 0, 1 and k minus 1 means whenever we will calculate SPK, we will consider these vertices. I mean, if I take the vertices as 0, 1 to n minus 1, so k minus 1, k will be something which is from 0 to 1. I mean, like I can take k equals 1 so that I can calculate SP1 such and up to SPN. Okay, so that we can vary 0 to 1. When we will take SP1, then our vertex, like that means we will only consider the edges which are connecting I to J via 0. Okay. When we will consider SPN, that means we will get 0 to n minus 1, right? If I follow this thing, that means we have to consider all possible paths in the graph connecting I to J. So if K is a particular vertex, which is like K is a member of this set, then that means K is a particular vertex, suppose, then we have to consider all the paths, all the combination, all possible paths which are passing through this vertex. Okay.
Thanks.
Got it?
Yes.
Okay.
Excuse me, ma'am.
Yeah.
In activity question 11.3, question number 2.
Okay. 11.3.
Yes.
Question number 2.
2. Yeah. Yes, ma'am.
Okay. So what is the question? We have given the adjacency matrix. So we use the multiplication to find A square. Then what are the values of A and B? Okay. Okay. So this is pretty simple, na? Like this is the given A. This is the given matrix A. Now you have to calculate A square. That means you have to just do the matrix multiplication, then compare these two matrices, and then just compare the entry. Did you get my point?
I got alpha as 0, ma'am, but the answer given is alpha as 1. TA session also still restricted, ma'am. The access is still restricted, so I can't refer there also.
0, 0. Okay, let us do that. So we can do this with matrix multiplication 0, 0, beta 1, 0, 0, 0, 0, 0, 1, and 0, 0, 0, 0, 0. Again, we have to write the same thing. 0, alpha, 0, 0, 1, 0, 0, 1, 0, 1. So if I 0, rest of them. Okay. So now just multiply it. So the first entry will be 0, 0, 0, 0, 0. Okay. 0. No problem. Okay. Then we will get 0, 0, 0, 0. Second entry will be again 0. The third entry will be 0, alpha.
It's not visible, ma'am.
You cannot visit?
It's not visible, ma'am.
I mean, you cannot visit the screen?
Yes, yes, ma'am. Visible.
Visible,
Yeah,
right?
now. Yes, ma'am.
Yeah, of course, visible.
Yeah. So now just third, then 0, alpha into 1, that means alpha. Then 0 into beta, 0 into 0, 0 into 0. So this is alpha, right? If we just, this is the third entry, that means 0, 1, and this is the entry. So if I just compare, we will get alpha equals 1. Okay?
Okay, ma'am. Okay.
Yeah.
Thank you, ma'am.
Yeah. So just square the matrix. I mean, just do the matrix multiplication and compare this to matrix, so you will get the answer. Okay.
Okay.
Okay. So yeah, I just let us solve this question. So this one was doubt, right?
Yeah, 53. Yeah.
Okay. So what is the question? Consider the weighted graph G with 7 vertices. In order we represent the okay. So we have a graph and we have the adjacency matrix. Suppose we perform the Prim's algorithm. Starting from button 1. Okay. So what is our first step? We have to draw the graph, right?
Yeah, of course. Can you please solve the
So V1, let us use. This color is not visible, na? Green color.
Yeah, visible.
Okay. We V4, V5.
Ma'am,
Yeah.
cannot we apply directly Prim's algorithm without drawing graph? Like
Yeah.
I've solved this question without drawing this graph. I've also solved this question.
Yeah, you can do this. I'm just like drawing the graph to simplify the problem. Nothing more than that.
Okay, okay.
Yeah, you can pick the smallest one and then you can grow like just following the adjacency matrix. But I want to simplify the graph. That's why I've drawn this. Okay.
Okay, okay.
Okay. So V1 to V2, we have a direct vertex with 24. If I am doing something wrong, then immediately let me know. Okay. V1 to V5, we have a direct vertex with 36. V1 to V7, we have, right?
Yes, ma'am.
Yeah. Then V2 to V2, V2 to V1, that means this is both sided, right?
Yes, it is undirected graph.
Yeah. So then again 2 to 4, 2 to 4, that means this edge with 32. No? Then 3 with 6, 3 to 6, that means this with 4. Then 3 to 7, 3 to 7 means this with 12. Then 4 to 2, 4 to 2. Okay, this is symmetric. That means the graph is undirected, na?
Yes, ma'am. So it's complete.
This is the graph, no? Or is there any other? What is this? Yeah. Sorry. With 20. V7 and V6. Then, is there any other vertices? V6, V5? No, right? 6 to 3 is connected. So this is the graph, na?
Yes, this is the graph.
So we want to use the Prim's method. So we have to first consider the edge with least weight. So what is the least weight? Is 4, right? That means this edge. Also, you can note 4 is the least here, and then you can see the edge. Okay, 3, 6 with 3. So V3. Is it okay?
Yes.
Okay, no. Suppose
Yes.
starting. Okay,
Yes,
you
okay.
have to start from V1. They have given the restriction.
Started V1, find the MST.
Okay, so we have to start from V1. Okay, then after V1, we will choose the vertex with least edge. No, so we will consider V2 then, right? Okay.
Why?
Because
V2, ma'am.
okay, so because we have V1.
V1, V2 is both, yeah.
So only we have these 3 options, right? I mean V1 to V7, which is 28. V1 to V5, which is 36, and V1 to V2, which is 24, which is least, right? So we will consider V2. Okay?
Yeah.
Is it fine? So once we consider V2, we will immediately discard these 2 options, right? Next, we have V1 and V2. So we have to now enlist one more edge I mean one more vertex which is connected either to V1 or to V2 and has the least weight. So we can consider V7 which is connected to V1, V5 which is connected to V1, V4 which is connected to V2. Only these three are the possible vertices, right? And we will now choose the vertex with least weight. And so 32, 36 and 28. So 28 is the least. So we will enlist V7 after that. Okay. Once we enlist V7, we will discard it and this will be the answer. Okay.
Still, V, I have not understand. Can you please again?
Okay. So you have to start with V1. Okay. Then we enlist V2 because of the least weight, right? The second step is clear, right?
Yes, clear.
Yeah. So we have V1, we have V2. Now we have to check all the vertices which are connected with either V1 or V2. So the possible vertices are V7, V5
Yeah,
and
of course.
V4.
Yeah, yes. Yes, ma'am,
Okay.
I am understanding.
Okay, you got it, right?
Okay, ma'am. Thank you, ma'am.
Yeah. Any other doubt?
Hello, ma'am.
No, curious, ma'am, this.
Yes.
Hello, ma'am.
Yeah.
Ma'am, activity 11.8, question number 3 that I asked you previously.
Okay, that tree, number of tree.
Yeah.
I can't remember anything like about number of tree. So let us check. How many spanning, okay, number of spanning tree are possible for the graph shown in AQ 12.5. That means this one. Okay.
Yeah. So I draw it, but I got only 6 trees.
Okay. So we need to like cover all the vertices. So we can do this. I mean, we can first do this, this, and this. This is one possible way. Okay, so we have to draw all the things. So this is quite time taking. Okay. So if I just follow this route, is there anything possible other than that? So we can take a second thing. Instead of this, we can take this. So this is a second. So was there any formula for this? I can't remember. Any one of you, do you remember any formula?
I actually don't know, ma'am, formula. I watched the lecture again, but didn't get the formula.
Yes, not formula.
Okay. So yeah, I also can't remember any formula. So maybe we have to just check it. So yeah, 0, 1, then 3, then this is a possible way. Then again, if I just take this, so this, then this, then this, then this. This is a possible way. There should be some formula kind of thing. I mean, this is not possible to sit and draw all possible spanning trees.
And then there is a chance of missing the.
Yeah, there is a chance
Yeah.
of missing one spanning tree. So there should something generalization of this. Let me just give me 2 minutes so think so that I can think about it. Okay, maybe we can use some combinatorics to do that. I mean, for 0, we have 2 options. But we can see one thing, that this graph is symmetric with respect to this line. So if I just follow this the way here, this will be twice of the half of the yeah. Okay, so we can draw this. Also, this is one thing is coming to my mind. This graph is symmetric with respect to this line. So if I consider all the possible ways which can follow this edges, so we can just flip them, and this will be a possible ways to just if you just flip this, so this will be again another possible way. So this can be shorter if we follow this, but still this is something, I mean, this cannot guarantee you find all the spanning trees. So you may use something general. Okay, just give me some time, let me think about it, then I will let you know in the next session about the general solution. Okay,
Sure, ma'am. Sure. Thank you, ma'am.
you can also try it with this hint, I mean the symmetric thing.
Ma'am, I tried with y axis as a mirror.
Yeah, this is also another possible thing, but still, is it like concluding something?
I got only 6.
Okay.
And the answer is 16, so there is 10 more to go.
Yeah. Okay, then there may be something general which I think, because it is not possible for anyone to sit and just draw all the spanning trees. So we may need to use some method
Yes, ma'am. Yes, because it is a simple graph, but
yeah,
what if it's a complex graph?
yeah. Okay, so right now I don't remember anything like that, but I will think about it and I will let you know in the next coming session. Just you have to remind me, okay?
Sure, ma'am.
Yeah, in the next session, please remind me about the problem. So I will, if I have the answer, then I will describe it, okay?
Okay, ma'am.
Any other doubt?
Ma'am, I have doubt in graded assignment 10.
Graded assignment we cannot solve.
I'm 10.
No, if you have doubt in week 11, then I will cover it. And also if you have doubt in week 10, then we will cover it in the revision session, because today we don't have that much time and you have the graded assignment deadline tomorrow. That's why I'm extending the class.
Okay, ma'am.
Yeah. So if any doubt from week 11, then let me know. Otherwise, we can end this session.
Today's session end.
Okay. Okay, so if you don't have any doubt, you can leave then.
Okay, ma'am. Thank you.
Yeah, welcome.
Thank you, ma'am.
Welcome.
Thank you, ma'am. Good night.
Good night.